Hi everyone, in this video we're going to talk about an application of radian measure, which we learned about in the last video. The application is called arc length, and before we do some examples, I just need to define two terms for you. The first is central angle. So the central angle is just the angle formed by two radii in a circle. So let's write that down. The angle formed by two radii of a circle. Arc length is the next term that we want to define, and it's basically the distance that we travel if we walk along the outside of a circle. So the distance traveled along the circumference of a circle and we'll say over the course of some angle. Because usually when we talk about arc length, we talk about it in reference to a central angle. So here's a quick example. If our central angle theta is pi over 8, so my central angle is pi over 8, and the circle has a radius of 4, then I want to know the arc length of the inscribed arc. So let's draw a picture here. So here's my circle. It has a radius of 4, and I've gone pi over 8 of the way around. So remember, this is measured in radians. If a full circle has 2 pi radians, then in order to get pi over 8, I need to separate the circle into 16 equal parts, because 2 pi over 16 is the same as pi over 8. So if I break this circle up into 16 equal parts, so that's 2. Now I've broken it into 4 equal parts. Now I've broken it into 8 equal parts. Now I've broken it into 16 equal parts. Then I'm talking about the angle theta, which is located in one of these. So that's pi over 8 radians. So the arc length is just going to be this distance. So what I want to do is notice that this arc length is just 1/16 of the full circumference of the circle. So it's 1/16 of the circumference. So what I'll do is I'll take the circumference, which is just 2 times pi times r, and divide that into 16 parts. And I'm given that r is 4, so I do 2 times pi times 4, divide it by 16, and that's going to give me 8 pi over 16, which is just pi over 2. So that's the arc length given by this problem. Now it's not always so easy when you're given the angle to figure out what fraction of the circle that represents. So there is a formula for calculating arc length, which we'll talk about now. Okay, so the formula for arc length. We usually denote arc length by the letter S. In order to get it, what I can do is just take theta and multiply it by the radius. So theta is the central angle, and r is the radius. So let's see how easy this is to do in these cases. So if my radius is 4 and the central angle that I'm given is theta, then I get the arc length by doing theta times the radius. So I get 15 pi over 4. Now if my radius is 1 then my arc length is going to be theta, which is pi over 6, times 1, which is just pi over 6. So this particular example is why using radians is so special, because if I measure my angle in radians and I have a circle of radius 1, then the angle that I'm interested in, so pi over 6 in the last video we learned that was 30 degrees, so it's about that big. So that angle measure is the same as the arc length if I measure my angle in radians. If I measure it in degrees, then I can't use this formula, so 30 degrees does not equal pi over 6 in distance. So this is why radians are so important, because they coincide with the arc length. Now finally, if the radius, this last example, if the radius is 10 and theta is pi over 4, then my arc length will be pi over 4 times 10, which is 10 pi over 4. So you'll notice that in these two examples I had the same angle but different radii. When the radius is longer but the angle's the same, the distance that we travel is longer, because the circumference of a bigger circle is going to be bigger. So these are just some examples of the computations and a brief explanation of why radians are so important. So come back to this formula and these examples whenever you're dealing with arc length.